What if the first sign of alien life did not arrive as a radio signal or a photograph, but as the chemical scent of an ocean 120 light years away? In April 2025, astronomers announced that the James Webb Space Telescope may have detected sulfur-bearing molecules in the atmosphere of a distant planet called K2 to 18b. One of them was dimethyl sulfide, or DMS, a gas that on Earth is produced mainly by marine microorganisms. It sounded as if Webb had somehow smelled an alien sea. But the telescope did not detect life, and it did not literally smell anything. It measured tiny changes in starlight, searching for chemical fingerprints so faint that different methods of processing the same data can produce very different answers. K2 to 18b is unlike any world in our solar system. It has a radius about 2.6 times that of Earth and a mass nearly 9 times greater. It completes an orbit around its cool red dwarf star every 33 days and lies within what astronomers call the habitable zone, the region where temperatures might allow liquid water under the right conditions. But a planet inside this zone is not automatically habitable. It may have no accessible surface. Its ocean may be too hot, or its atmosphere may create pressures that no known organism could survive. When K2 to 18b passes in front of its star, a small amount of starlight filters through the planet's atmosphere. Molecules absorb particular wavelengths, leaving patterns in the spectrum that act like chemical fingerprints. In 2023, Webb observations revealed strong evidence for methane and also reported carbon dioxide in a hydrogen-rich atmosphere. Methane remains the more secure result, while the strength of the carbon dioxide signal depends somewhat on how the data are analyzed. The same observations contained a much weaker hint of DMS. It was intriguing, but far too uncertain to call a discovery. Then came the dramatic claim of 2025. Using Webb's mid-infrared instrument, or MIRI, one research team reported features that could be explained by DMS, dimethyl disulfide, known as DMDS, or a mixture of both. The signal reached roughly 3 sigma significance. That sounded impressive, and headlines quickly described it as one of the strongest hints of biological activity ever found beyond Earth. But 3 sigma does not mean there is a 99.7% probability that life exists on K2 to 18b. It only describes how unusual the data appear under a particular statistical model with particular assumptions about the molecules and the instrument's noise. Change those assumptions, and the apparent certainty can change with them. Other scientists soon raised serious objections. DMS and DMDS produce broad, overlapping, spectral features that can be confused with other molecules. The result also proved sensitive to how the spectrum was divided into wavelength bins and how instrumental effects were removed. When independent teams reprocessed the full set of Webb observations, several found no statistically significant evidence for either DMS or DMDS. One analysis concluded that time-correlated instrumental noise, known as red noise, could be creating features that looked planetary, but were not. Newer atmospheric models have also reproduced the available spectrum without requiring either sulfur molecule. And even if DMS were eventually confirmed, scientists would still have to eliminate unknown, non-biological chemistry before treating it as evidence of life. Beneath this argument lies an even greater mystery. No one knows what K218b truly is. One possibility is a Hycean world, a vast, dark ocean, hidden beneath a thick blanket of hydrogen clouds. In that scenario, the atmosphere might contain chemistry, influenced by life, in waters no telescope can directly see. But another possibility is far more hostile. A hazy mini-Neptune with a crushing atmosphere, a deep, hot interior, and no habitable ocean or surface at all. From 120 light years away, both worlds can leave frustratingly similar fingerprints in starlight. More observations may eventually reveal which interpretation is correct. For now, however, K2-18b remains suspended between two extraordinary possibilities. Perhaps JWST has detected the chemistry of an alien ocean. Or perhaps we are hearing noise and turning it into the answer we desperately want. K2-18b has not given us proof of life. It has given us something more dangerous: hope.